The storm over the Nevada basin gathered without warning, static rolling through a sky that had been crystal clear moments before. The array stood beneath the turbulence, a sprawling lattice of titanium spires and containment rings sunk deep into the desert bedrock. From orbit, it appeared as a luminous scar of pale blue light, pulsing with the rhythm of a living heart. Inside the complex, Dr. Alara Kovac watched the cascading data with a growing sense of disquiet. The readings defied every established principle. Neutrino scatter had spiked, and decoherence values were collapsing at impossible rates. She had spent 7 relentless years constructing the array, fighting for funding through black channels and classified defense initiatives that never explained their true intent. The stated purpose had been research, to generate a controlled quantum overlap between adjacent branes of spacetime. But even she had known that the boundaries of theory and weaponization were dangerously close. Deep beneath the facility, containment rings began to hum, their vibrations seeping through the reinforced floor. The harmonic frequencies climbed beyond audible range, and then something inside the chamber shifted. Air pressure folded inward, and a shimmer appeared at the center of the array. For a moment, the phenomenon resembled heat haze, a translucent veil warping the geometry around it. The light bent in unnatural ways, revealing fragments of shadow that did not belong to their world. The chamber's power conduits flared white. Coolant drones scuttled along the metal rails, and Alara felt the vibrations travel through the bones of her arms as she steadied herself on the console. She recognized the signal pattern forming across the sensors. The project had finally achieved what generations of physicists had dismissed as impossible: contact across the boundaries of reality. The event lasted no more than 8 seconds. Then, without warning, the resonance collapsed. Every monitor in the control room went black. Silence filled the facility for a heartbeat before the alarms began their mechanical scream. Across the array, containment fields failed in sequence. The central power node flickered, throwing jagged shadows across the walls. Somewhere in the noise, a deep metallic groan rose from the structure itself, a sound like the planet exhaling under strain. The command deck descended into chaos. Technicians scrambled to isolate circuits, but the interference was unlike anything they had modeled. It carried patterns that seemed almost intentional, structured, as if something from beyond was probing the system's architecture. When the feed returned, the first image on the main display froze everyone in place. On the screen was the control room itself, identical in every respect. The same consoles, the same instruments, the same array of faces lit by the same blue glow. But the figures inside moved a fraction of a second out of sync, like echoes from a delayed reflection. One of the figures turned toward the camera, her eyes locking with Alara's through the digital haze. It was her own face, mirrored and expressionless, staring back with silent awareness. The image fractured into static and then vanished. By dawn, the Nevada Basin complex was surrounded by unmarked transport aircraft and autonomous defense drones. The project had been absorbed by the Strategic Science Corps, a division that did not officially exist. Every scientist was isolated in debrief pods, interrogated through encrypted channels. The military believed the event was a breach, an intrusion rather than an experiment gone right. Alara understood the pattern differently. She recognized it not as invasion but as acknowledgement, a signal of recognition from an adjacent existence. Yet the thought brought little comfort. For every discovery humanity had made, there had always been a price measured in chaos. 2 days after the incident, she was transferred to Odyssey Station, an orbital command hub circling 300 kilometers above Earth. The station had originally been designed as a missile detection platform, but was now hastily reconfigured for dimensional telemetry. Its long central spine gleamed under solar light, flanked by sensor arrays like wings. Inside its pressure hull, air recycled through narrow corridors that smelled faintly of ozone and metal. Commander Rafe Marlin, the officer assigned to oversee containment operations, treated the new mission with cold efficiency. His experience as a squadron leader in orbital combat left him skeptical of scientists who tampered with forces they barely understood. Yet even he could sense that what had occurred on Earth was not merely an experiment, but an event that would alter military doctrine forever. Within the station's laboratory modules, Alara and her analytical team reconstructed the data from the incident. The resonance pulses, when mapped in temporal sequence, formed a rhythmic pattern, almost biological in regularity. The signature repeated every 13 hours, a cycle that suggested intent rather than accident. If the pulses were indeed returning from another brain, then the other side was attempting communication. The realization unsettled the entire command structure. Protocol dictated that any contact beyond known parameters must be treated as potentially hostile until proven otherwise. At the 13th hour, the station's proximity sensors detected a disturbance. Space itself appeared to bend just beyond the orbital perimeter. A faint distortion formed, an afterimage coalescing into the silhouette of another station, an exact mirror of Odyssey, suspended like a reflection in black glass. Its navigation lights blinked in identical rhythm, its geometry precise down to the smallest antenna. For several minutes, the twin structure remained visible, then faded into invisibility. The observation confirmed the impossible. The overlap was expanding into orbit. The following encounter arrived without warning. A kinetic impact rocked the hull, silent in the vacuum yet forceful enough to shear one of the outer trusses clean away. No missile had been launched, no projectile tracked. The strike had originated from nowhere measurable, as if momentum itself had been borrowed from another plane. Internal sensors reported localized gravitational shear along the damaged sector. The station's defenses were designed to counter tangible threats, missiles, drones, energy signatures, not assaults from within the folds of physics. Yet, as power redistributed through the grid, a faint resonance bled through the communications array. It matched the same quantum frequency as the array's initial breach. Something, or someone, was targeting them through the dimensional bridge. Rafe's decision to respond was immediate. Power was diverted to the magnetofield generators, enveloping the station in a cocoon of charged plasma. The next impact scattered against the energized hull, dissipating in a burst of light visible even to ground-based telescopes. For the first time, their defense systems registered resistance. The counterfield had worked, but as the sensors adjusted to the feedback, the mirror station reappeared, brighter, sharper, its surface marked with unfamiliar black insignias. Movement was visible along its observation decks, but the figures inside did not move like ordinary humans. Their synchronization was absolute, mechanical in precision, each gesture a reflection of collective intent. Alara recognized with growing dread that these were not alternate versions of their crew, but engineered counterparts, entities shaped from perfect symmetry and stripped of variance. Whoever or whatever had constructed them had done so with a purpose beyond exploration. The second attack came harder. The mirror station emitted a pulse that bypassed their shields entirely, overloading the grid in seconds. Gravity plating failed. Consoles erupted in sparks. The Odyssey shuddered as smoke filled its corridors. Life support systems flickered, automated dampers sealed compartments, and emergency lighting bathed the interior in blood-red glow. The crew scrambled to stabilize rotation while the outer decks vented atmosphere into space. For several agonizing minutes, the station teetered on the edge of systemic collapse. Then, abruptly, the assault ceased. The distortion folded inward once more, and the twin station dissolved into the void. In its wake came a fragmentary transmission buried within the noise. The data translated into a single human voice, fragmented and panicked. The timbre was unmistakable. It was Alara's own voice, distorted through interference, pleading for help from somewhere beyond the bridge. The words unsettled the crew as much as the commander. If a version of Alara existed on the other side, she, or it, had lost control of whatever force ruled the mirror station. The transmission implied not malice, but desperation, as though the enemy they had glimpsed was no longer in command of itself. The thought of an entire parallel world subjugated by its own creation cast a shadow across every discussion that followed. Repairs occupied the next 26 hours. The damaged truss was sealed with carbon fiber foam, and auxiliary power cells were rerouted to keep the life support grid stable. Efficiency dropped. Heat management became precarious, and the air grew stale with recycled breath. Alara worked in silence through the long orbital night. She reviewed every byte of telemetry, every fluctuation in the resonance window, searching for intent. What emerged was a pattern she could no longer deny. The interference peaks were structured like signals, encoded packets that carried information, possibly even coordinates. If deciphered, they could reveal the origin of the alternate brain. Yet to open that channel again would invite another breach. The balance between discovery and annihilation had never felt thinner. The next resonance cycle arrived with perfect precision. This time, Alara's modifications to the particle array altered the field from repulsion to stabilization. The objective was to hold the overlap long enough for direct observation, perhaps communication. The commanders treated the maneuver as a calculated risk, aware that the slightest miscalibration could rupture the hull itself. As the array powered up, space before the viewport began to ripple again, stars bending into a spiral of refracted light. The distortion stabilized into the same mirror structure. Odyssey reflected against infinity, but now it remained fixed in position. The bridge had been forced open. Energy signatures on both sides synchronized. For a moment, equilibrium existed between worlds. Streams of data flickered across the monitors as two identical systems attempted to communicate. Then, faintly, telemetry from the mirrored station indicated irregular movement beyond its perimeter. Unknown craft emerged from shadow, their forms angular, insectoid, and disturbingly precise. They moved in formation toward the mirrored station, accelerating with impossible grace. Within seconds, bursts of silent light erupted across its hull. The black-marked Odyssey was being attacked, not by them, but by something else. The resonance between the stations began to destabilize. Shockwaves of energy rolled through the overlap, threatening to drag both structures into collapse. Power surged through the Odyssey's systems as the field buckled. Inside the blinding distortion, a single craft detached from the destruction on the far side. Sleek and dark, it shimmered as it crossed the threshold between realities. For an instant, its surface flickered between states, matter and light occupying the same space. Then it solidified, existing wholly within their orbit. The resonance field disintegrated behind it, severing all connection to the other universe. When the glare faded, the craft hung silent before Odyssey Station. Its hull gleamed with shifting colors beyond visible spectrum, its design alien yet familiar in the cruel efficiency of its lines. It was not theirs. It was not entirely human. And it had come through intact. As the crew struggled to recover power and reorient the station, the object rotated slowly, aligning itself with their main viewport. Energy built along its flanks, forming a pulse of light that no known weapon system could match. The sensors overloaded before any analysis could complete. For a single suspended heartbeat, the universe seemed to hold its breath once more. Then the craft fired. The blast from the alien craft ripped through the station's outer shield, bending the air within the pressurized corridors even as the vacuum of space drew at the hull. Panels buckled under the force, and sensor relays failed in a cascade that left the command deck in near darkness. The hum of life support systems stuttered, only partially compensated by auxiliary reserves, as emergency lighting cast jagged shadows over the crew scrambling to maintain stability. The station tilted imperceptibly in orbit, a shift measured only by the gyroscopes and magnetic dampers that strained to keep the hull from twisting under the sudden torque. Alara's mind raced through sensor logs, telemetry streams, and quantum resonance arrays, trying to reconstruct the geometry of the assault. The craft's origin remained unreadable. No trajectory, no heat signature, no spectral data. It existed as a coherent object only within their reality, yet had clearly been birthed from the overlap with the parallel station. Damage teams were dispatched through magnetized corridors toward breaches in the aft truss, where hull plating had buckled and composite armor split. Robots scuttled alongside humans, carrying modular patches of carbon-carbon composite, deploying them into open vacuum before welding them in place with laser seams. Gravity plating compensated for the loss of structural integrity. Yet the station shuddered with each impact, every repaired truss testing the limits of the magnetic stabilizers. Fuel reserves for the secondary thrusters were being drawn at alarming rates, used not for orbital adjustment, but for station stabilization in response to unpredictable forces. Each correction brought them closer to resource exhaustion. Yet there was no choice. The alien craft remained poised for a follow-up strike, its energy signature bristling against any sensor attempt at classification. Alara coordinated the analytical response. The resonance field from the mirror station had left residual patterns in their instruments, echoes of interference that suggested the craft's propulsion and weapons operated on phased energy, partially existing in an alternate quantum state. Attempting conventional countermeasures risked catastrophic feedback. Even firing a railgun into vacuum might destabilize local spacetime in unpredictable ways. Instead, she calculated a phased counterlattice using the station's particle arrays, rerouting power from orbital sensors to generate oscillating electromagnetic fields in precise synchrony with the alien craft's phase signature. The oscillation had to match frequency, amplitude, and temporal offset within microseconds. Any error could invert the field and amplify the next attack. Hours of computations condensed into seconds of execution as her fingers danced across the console, stabilizing the lattice to form a semi-cohesive barrier around Odyssey's vulnerable sections. Meanwhile, Commander Marlin directed the orbital defense drones into calculated interception patterns, positioning them between the alien object and the station's most critical modules. The drones' guidance systems were conventional, incapable of locking onto phased targets directly, but their presence forced the aliens' projected force to spread across multiple vectors. Each drone, heavily armored and equipped with micro-explosive containment charges, acted as both shield and sensor, transmitting interference readings that Alara fed into her calculations. The drones themselves were expendable, yet Marlin monitored them as though they were extensions of his own limbs. He recognized the asymmetry of the conflict. Technology and human ingenuity were the only tools capable of leveling a battle that the universe itself seemed designed to favor against them. As the hours passed, the alien craft appeared to recognize the countermeasures. Adjusting its trajectory subtly, weaving between drones, its energy pulses deflected in part but not neutralized. Its design revealed more with each approach. Sleek, segmented armor plates that shifted with the craft's movement, creating a shimmering visual distortion that mimicked refractive bending. The object's energy core glowed intermittently, and in the brief flashes of visible spectrum, patterns emerged that suggested adaptive computation, as though the craft was learning from their responses. Each pulse of its weapons, while less damaging than the initial blast, carried an efficiency that eliminated redundant defenses. Odyssey Station's systems groaned under constant load, operating on the margin of failure, while human operators anticipated variables in real time, improvising sequences of field adjustments that combined science and instinct. In parallel, Alara continued to analyze the resonance remnants left by the mirror station. They revealed something profoundly disconcerting. The craft was not merely an extension of another Earth, but a weaponized fragment of it capable of interfacing with reality itself. The patterns suggested that the mirror civilization, whatever its motivations, had integrated automated defense with real-time quantum monitoring, enabling phased matter manipulation at both offensive and defensive levels. Odyssey's crew began to understand that conventional communication, signals, frequencies, and coded transmission, might be useless. The interface was not digital. It was structural, operating at a quantum physical level that intertwined matter, energy, and perception. Amid this pressure, the crew's morale strained. Microgravity corridors became a theater of constant motion, with technicians magnetically tethered as they recalibrated emergency circuits, replaced damaged sensors, or deployed field drones. Sleep cycles were disrupted. Fatigue etched itself into faces previously unflappable, even among the hardened officers of the Strategic Science Corps. Yet discipline persisted. Each crew member functioned like a node in a distributed intelligence, processing local contingencies while anticipating global implications. Alara's awareness of the alien craft's movements, coupled with Marlin's tactical oversight, created a feedback loop of human-machine coordination that allowed temporary stabilization, even as supplies dwindled and structural integrity eroded in microfractures invisible to the naked eye. 3 critical breakthroughs occurred simultaneously. First, a pattern of energy reflection off the craft's phased surface suggested an exploitable lag. The phased material responded fractionally behind applied counterfields. Second, telemetry from the destroyed mirror station had left residual digital echoes which, once decoded, revealed the alien's operational cadence. Third, minor distortions in local gravity fields around Odyssey indicated that their own lattice field could be extended outward, creating a controlled bubble where phase misalignment could be induced artificially. These insights formed the basis of a daring plan. Instead of direct attack, the station would attempt to manipulate the craft's phase coherence, forcing it partially into their plane where defensive measures could engage it fully. Execution required near-perfect coordination. Auxiliary power modules were stripped from non-essential systems, overloading thermal regulators to drive peak output in the lattice arrays. Drones were repositioned to maximize interference while maintaining protective coverage of critical modules. Odyssey's rotation was altered subtly to align its structural mass with the predicted phase bubble. Every second brought risk. Misalignment could tear the station apart or amplify the alien's energy pulses. Yet the team executed with mechanical precision, relying on intuition honed through years of orbital operations, combined with deep understanding of the resonance mechanics. Time itself seemed to stretch, each decision compounding across multiple vectors. The alien craft reacted almost immediately. Its trajectory oscillated, adaptive sensors flaring in bursts of light that illuminated the interior of Odyssey with spectral hues beyond visible spectrum. The lattice arrays responded, oscillating their fields with amplified microsecond precision. For a tense hour, the two forces interacted in a dance of countervailing quantum pressures. Each oscillation left a trace in the station's sensors, a fingerprint of energy, mass, and phase. The crew tracked the data in real time, adjusting fields with incremental tweaks that required both calculation and instinct. The alien pulses, once unpredictable, began to follow a discernible pattern, gradually losing their efficiency as the station's manipulations imposed microphase misalignments across the craft's surface. By the third cycle, minor damage control became feasible. Hull fractures stabilized, microgravity shifts dampened, and auxiliary power surges could be directed back to life support. Yet the alien remained active, a sentinel of unknown intent, and the residual echoes from the destroyed mirror station continued to suggest urgency, perhaps a warning of consequences beyond comprehension. Odyssey Station had achieved temporary equilibrium, but the operation had exposed critical weaknesses: finite energy reserves, structural brittleness, and the existential threat posed by another world whose technological development mirrored, yet diverged from their own. In the aftermath, the crew's focus shifted to preparation and adaptation. Data streams from the resonance field were archived, analyzed, and tested against computational simulations of phased interaction. Scenarios were constructed for potential breach events, each accounting for structural integrity, crew survival, and orbital stability. Microfractures in hull panels were reinforced, emergency procedures rehearsed, and contingency matrices expanded to include multiple dimensional incursion patterns. Despite the tension, patterns of resilience emerged. The interplay of human judgment and scientific insight, tactical discipline and improvisation, created a framework capable of holding against unknown variables. It was a fragile equilibrium, but one that could be refined. Yet even in this temporary calm, the consequences of their discoveries pressed relentlessly. The alien craft, now stabilized in orbit, remained a persistent variable. It hovered like a sentinel, silent but active, its phased systems intermittently interfacing with Odyssey's lattice fields. Each fluctuation sent ripples through the station's sensors, a reminder that the overlap with a parallel reality was no theoretical abstraction. The universe had revealed its vulnerability, and the implications of that revelation stretched far beyond orbital operations or even human comprehension. Odyssey Station was no longer merely a defense platform. It was a fulcrum at the intersection of realities, balancing human ingenuity against forces that were at once familiar and alien. The station's crew understood that the next phase of engagement would not merely test their tactical skill, but the limits of their endurance, creativity, and moral resolve. The first incursion had been survived through adaptation, observation, and precise manipulation of quantum forces. But the alien craft had remained intact, active and unpredictable. Its continued presence transformed the orbital theater into a crucible of escalating stakes. Each decision would carry consequences magnified across dimensions, with failure potentially propagating into realities not yet understood. Odyssey's crew prepared themselves for the next engagement, knowing that survival depended on relentless vigilance, coordination, and an unyielding commitment to understanding a force that bent the rules of existence itself. And beyond the temporary victories, the echoes of the mirror station haunted every calculation, a reminder that what they faced was not merely another Earth, but a reflection of possibility turned into an unknown adversary. Odyssey's station drifted in orbit under an uneasy equilibrium. The alien craft remained poised nearby, a silent reminder that the bridge between realities had not closed, that their actions resonated across dimensions, with consequences they could neither fully predict nor control. Inside the station, crew members worked in shifts that blurred night and day, tending to lattice arrays, calibrating sensors, and monitoring structural strain. The repairs were painstaking. Hull panels had been reinforced with layered composites. Micrometeorite shields adjusted to compensate for fluctuating mass displacement, and auxiliary generators were rerouted to prioritize both shields and life support. Every adjustment, every minor repair, was a gamble against the unpredictable phase distortions radiating from the alien vessel. In the command deck, Alara meticulously analyzed the interference data from the previous engagements. Each pulse, each disruption, left a subtle imprint in the quantum lattice that allowed her to begin mapping the craft's operational pattern. Over repeated cycles, the echoes revealed a faint but consistent rhythm, like a heartbeat synchronized to a variable frequency. The pattern was not merely random, it suggested strategy, possibly even cognition, filtered through an unfamiliar interface of physics. Odyssey's crew began to realize that this was not simply a vessel, it was a system designed to observe, react, and exploit. Its coordination implied intelligence, whether biological, artificial, or a combination of both. Tactical planning evolved rapidly. Commander Marlin ordered the repositioning of all operational drones into multi-vector formations. These arrays were designed to create overlapping fields of interference, leveraging Odyssey's particle arrays to generate temporary pockets of phase misalignment. The intent was to force the craft partially into their reality, where kinetic systems could engage. Each drone's path was calculated to sub-millisecond precision, accounting for latency, energy dissipation, and structural load across the station's trusses. Minor miscalculations could result in catastrophic collisions or the unintended collapse of critical modules. Yet, despite the danger, the crew executed each maneuver with methodical precision. The operation became a choreography of human, robotic, and quantum systems, each acting as a single organism with hundreds of interdependent nodes. As the orbital shift carried Odyssey over the dark side of Earth, the alien craft adjusted its own orbit, shadowing them with uncanny precision. It maneuvered in ways that defied conventional propulsion, vanishing and reappearing in microseconds, along vectors that violated expected inertia. The phased energy pulses it emitted struck at the edges of their lattice shields, bending and refracting unpredictably. The station's hull vibrated with each encounter, a deep, resonant thrumming that echoed through the magnetic dampers. It became clear that the craft's designers had integrated multidimensional control into its very structure, using phase displacement as both propulsion and weapon. Any attempt at conventional countermeasures had to be adapted to account for the aliens' ability to exist partially outside their measurable reality. In response, Alara implemented a new tactic, deliberately creating micro-instabilities within their own lattice field to act as a lure. By projecting small, high-frequency oscillations outward, the station generated localized distortions that simulated vulnerable sectors. The hope was to provoke the alien craft into overextending, to force it to manifest fully within their reality long enough for drones or rail systems to strike. Initial tests were perilous. One miscalculation sent a localized shockwave through the aft truss, tearing auxiliary conduits and forcing emergency venting of the atmosphere. Several technicians were injured, though no fatalities occurred. The operation demanded constant adjustment, blending rapid computation with human intuition. It became an exercise in anticipation, predicting the craft's adaptive responses while safeguarding the station from self-inflicted damage. Over the following cycles, Odyssey's systems recorded increasing evidence of external adaptation. The alien craft began to react to micro-instabilities, predictably, avoiding lures, countering oscillations with subtle phase adjustments. Yet the repeated exposure allowed the crew to refine models of its operational logic. Each energy pulse, each evasive maneuver was cataloged, transformed into probability matrices that informed subsequent strategies. The approach evolved into a war of inference. The crew no longer relied solely on raw firepower or brute shielding. They attempted to outthink the craft, to manipulate its quantum phase reactions, and to exploit the patterns emerging from its rhythm of observation and attack. As their understanding deepened, the strategic goal shifted from defense to offense. Odyssey's crew identified potential points of vulnerability within the craft's phased envelope, sections where the overlap between realities was thinner, where the aliens' coherence with their dimension fluctuated enough to permit kinetic intervention. Alara calculated that with sufficient synchronization, Drones equipped with high-density projectiles could strike these points without risk of phasing through harmlessly. The operation would require perfect timing, exploiting a narrow window during which the craft's phase interface momentarily stabilized against the station's lattice. Failure could mean the drones disintegrating mid-flight or rebounding energy pulses tearing through Odyssey's hull. The first offensive sortie was launched under careful observation. Drones accelerated along calculated vectors, their sensors streaming live telemetry to the command deck. The alien craft detected them immediately, reacting with phased maneuvers designed to counter or evade. The interaction resembled a quantum chessboard, each move creating ripples across multiple planes of reality. Yet the preparatory oscillations proved effective. One drone penetrated the thin phase window, striking a segment of the craft's hull and leaving a visible scorch pattern, proof that the interface could be manipulated. The station's crew monitored the event with a mixture of exhilaration and apprehension. This minor victory, though fleeting, validated months of calculation and risk. However, the engagement came at a cost. Phase recoil from the strike propagated back into Odyssey's lattice field, overloading several stabilizers. Structural panels along the ventral trusses cracked under the pressure, releasing microfractured debris into the corridors. The station shuddered violently as emergency systems engaged, compensating for shifts in momentum. Power relays flared under sudden load, forcing auxiliary generators to cycle rapidly to avoid complete failure. Crew members navigated the corridors under partial gravity, carrying heavy reinforcement modules while dodging debris. The precision of human action proved as critical as the sophistication of the technology. Each success was measured in incremental survival, each maneuver honed through trial, observation, and improvisation under relentless pressure. Despite the damage, the offensive provided critical intelligence. Analysis of the craft's reactions revealed subtle dependencies on localized resonance fields, weaknesses in its adaptive shielding, and a recurring delay in phase correction when external energy pulses exceeded specific thresholds. Halara's calculations converted these observations into operational templates, guiding the deployment of subsequent sorties. Each mission became increasingly ambitious. Drones launched simultaneously along multiple vectors, auxiliary shields projected, particle arrays oscillating in tandem. The pattern of engagement was no longer reactive. It had become preemptive. Odyssey Station's crew began shaping the battle, exploiting the aliens' operational tempo rather than merely surviving its attacks. Yet progress was shadowed by growing internal tension. The station's limited resources forced difficult decisions. Prioritization of lattice power versus life support, deployment of drones at risk of destruction, rationing of human endurance through grueling shift cycles. Crew fatigue and stress were compounded by uncertainty. The alien craft's true intent remained unknowable. Its existence, a product of another Earth, carried moral ambiguity. Whether to destroy it outright or attempt communication weighed on every decision. The stakes were amplified by the understanding that failure could propagate consequences across dimensions, potentially destabilizing more than their immediate orbit. In the midst of these operations, a deeper insight emerged. Residual echoes from the destroyed mirror station suggested that their parallel counterparts had been engaged in similar defensive adaptations, struggling against forces they no longer fully controlled. It became evident that the alien craft was not autonomous in the sense of sentience alone, but was a weaponized extension of a world in crisis, partially automated, partially guided by unseen intent. The realization reframed the conflict. Odyssey Station was not merely defending itself, but operating within a larger, multi-dimensional theater where strategy, timing, and ethical restraint were equally critical. Each offensive maneuver was both an attack and a probe, extracting data while avoiding catastrophic escalation. As sorties continued, incremental gains accumulated. Microfractures in the craft's phased envelope expanded, giving drones repeated access to vulnerable points. Structural damage became visible, though temporary, as the alien interface corrected itself in delayed cycles. Odyssey's crew leveraged these windows to map the craft's internal architecture indirectly, forming a preliminary model of its energy conduits, propulsion, and shielding mechanisms. Every strike, every observation refined their understanding, enabling more precise operations. The operation became a sophisticated cycle of engagement. Observation, manipulation, strike, assessment, adjustment. Yet the battle was far from resolved. In one critical engagement, a miscalculation in the timing of lattice oscillations caused a localized feedback loop. The station's aft truss vibrated violently, tearing auxiliary conduits and forcing emergency venting of atmosphere from secondary modules. Several drones were lost instantly, disintegrated within the phase interface before reaching the craft. The alien responded with rapid energy pulses, exploiting the temporary instability, and Odyssey's structural integrity dropped to critical thresholds. For the first time, the crew realized that even minor errors could cascade across multiple systems, risking the station itself. Recovery was painstaking, requiring hours of manual reinforcement, recalibration of energy arrays, and redistribution of power across non-essential systems. The lesson was clear. Offensive maneuvers carried proportional risk, and success demanded flawless coordination of human Robotic and quantum systems, the cumulative strain, both physical and psychological, intensified as the alien craft persisted. Its patterns were now partially decoded, yet its intent remained uncertain. The station's crew worked in continuous cycles, oscillating between offensive sorties and defensive stabilization. Repairs became operations in themselves, an intricate choreography of human action and technological response. Each minor success brought insight and incremental advantage, yet each engagement reminded them of the precariousness of their position. Odyssey Station existed at the intersection of realities, a fulcrum of strategic and ethical decisions, whose consequences were magnified across dimensions. As the orbital night deepened, the alien craft emerged from its intermittent concealment once more. Its trajectory suggested a preparation for a concentrated maneuver, exploiting the accumulated stress within Odyssey systems. The crew braced, fully aware that the coming engagement would test every lesson learned. The strategies of observation, manipulation, and phased intervention would be executed under maximal strain. All previous sorties and calculations culminated in this moment, where anticipation and improvisation would determine survival. The alien craft's energy pulses intensified. The oscillations within Odyssey's lattice increased, and the station prepared for what might be a decisive clash. The next wave of engagement was imminent. The balance of tactical advantage, human endurance, and multidimensional physics would be tested beyond any previous threshold. Odyssey Station, battered but unbroken, stood poised to exploit the vulnerabilities it had painstakingly uncovered. The alien craft, adaptive and enigmatic, loomed as both threat and puzzle. Within the hum of magnetic dampers, the pulse of auxiliary generators, and the faint vibrations of stressed hull panels, the crew understood the stakes. Survival depended on relentless coordination, precise execution, and the courage to operate in a theater where every action resonated across realities. And as the first energy pulses of the coming engagement illuminated the station, a grim certainty settled among them. The war had only begun. Odyssey Station trembled under the strain of constant engagement. Every hull panel bore the memory of previous collisions. The lattice arrays hummed with near-continuous oscillation, and auxiliary systems operated at maximum threshold. The alien craft remained poised nearby, its phase interface subtly shifting, observing and responding to every maneuver. The station's crew had spent weeks decoding its rhythm, yet uncertainty remained. The cumulative damage to structural supports, the fatigue etched into human operators, and the finite energy reserves coalesced into a pressing reality. The next engagement could determine survival or annihilation. The operation was unprecedented in its scale and precision. Commander Marlin orchestrated Odyssey's systems with a level of coordination that merged human judgment with algorithmic prediction. Drones were arrayed in intersecting vectors, particle arrays oscillated with high-frequency modulation, and the station's auxiliary thrusters performed continuous micro-corrections to maintain optimal orientation. The plan relied on forcing the alien craft into a controlled phase bubble, a three-dimensional pocket of manipulated space-time where kinetic intervention could be effective. The margin for error was infinitesimal. Any misalignment risked tearing the station apart or allowing the craft to escape entirely, and yet hesitation was unacceptable. The aliens' previous attacks had demonstrated both precision and lethality. As the maneuver began, the alien craft reacted with immediate awareness. Its movement was a blur across space, employing sudden bursts of acceleration that defied conventional physics. Energy pulses struck the outer hull in rapid succession, each met with precisely phased counterfields generated by Odyssey's lattice. The station quaked under the interactions, yet its internal dampers compensated enough to prevent structural collapse. Crew members secured themselves to the magnetized floors, their muscles straining against microgravity as they monitored sensors, recalibrated shields, and prepared drones for immediate deployment. Every action required split-second timing. Failure was not an option. The drones launched simultaneously along intersecting vectors, each equipped with high-density kinetic projectiles. They moved like synchronized swarms, their paths calculated to exploit micro-instabilities in the craft's phased envelope. The alien responded with near-instantaneous evasion, yet the projected phase bubble held, a lattice of controlled interference compressing the craft's movements. Moments of partial manifestation allowed the drones to strike, piercing sections of its hull and leaving small but significant damage. The station's monitors displayed the effects in vivid detail. Streaks of residual energy from phase misalignment, slight distortions where matter briefly collapsed into semi-coherence, and subtle fluctuations in the craft's energy output. Each strike validated the painstaking calculations of the crew. Yet victory was never without cost. The feedback from the drone impacts generated localized surges that stressed Odyssey's lattice beyond prior thresholds. Auxiliary generators overloaded, forcing automatic shutdown of non-critical systems. Gravity dampers in the aft trusses shuddered, and emergency venting released small amounts of atmosphere to relieve pressure. Several drones were lost entirely, vaporized as they intersected with residual energy fields. Human operators navigated through corridors flickering with warning lights, manually reinforcing conduits and recalibrating sensors under extreme conditions. Fatigue and anxiety weighed heavily, but focus remained absolute. The operation required precision at every level. During the engagement, residual telemetry from the destroyed mirror station revealed additional insight. Analysis suggested that the alien craft's behavior was not entirely autonomous. It responded to cues, possibly originating from a network of phased sensors dispersed across its original world. Its movements were optimized for multidimensional conflict, yet delayed signals introduced exploitable lag. This revelation informed the next phase of the assault. By projecting synthetic interference patterns outward, Odyssey could manipulate the craft's phase alignment, guiding it toward the densest concentration of drones while minimizing risk to critical modules. The strategy demanded flawless execution, relying on the synchronization of human oversight, robotic precision, and quantum field manipulation. The craft's counter-response was rapid and adaptive. It emitted bursts of energy designed to destabilize the station's interference lattice, producing harmonic distortions that reverberated across structural supports. Panels buckled under stress, emergency lights flickered, and localized magnetic surges threatened to disable auxiliary systems. Alara recalibrated the lattice in real time, using predictive algorithms to anticipate the craft's next movement. The oscillations stabilized just enough for drones to execute another wave of high-density strikes. Each successful hit further compromised the craft's structural integrity, yet every action risked feedback that could tear through Odyssey's hull. The tension was unbearable. The station existed at the threshold of failure, and the crew's endurance was as critical as any calculation. As the offensive continued, a critical vulnerability was exploited. Analysis revealed a segment of the craft where phase coherence fluctuated most predictably, a narrow envelope where energy flow lagged behind structural adjustments. Drones were concentrated along this vector, and synchronized lattice pulses compressed the envelope further, forcing the craft to materialize almost fully within their dimension. Projectiles impacted the exposed sections, producing localized disintegration and visible breaches. The alien interface responded with instability, emitting erratic energy bursts that threatened to overwhelm adjacent trusses. The station shuddered violently, and emergency protocols were enacted. Crew members secured themselves, reinforcing critical conduits and cycling auxiliary power to shields, while recalibrating lattice oscillations to absorb the recoil. Amid the chaos, individual acts of sacrifice became decisive. Technicians navigated microgravity corridors, manually rerouting power and reinforcing structural nodes in sections exposed to residual energy pulses. Several drones were deployed beyond their programmed thresholds, risking disintegration to draw the craft's attention and allow other units to strike with greater precision. Crew members rotated tirelessly, monitoring systems and performing repairs with minimal rest. Human endurance became a force multiplier, as critical judgment and improvisation compensated for the limits of both technology and physics. Each act, each decision, created a ripple across the theater of engagement, influencing the outcome in ways measurable only in microseconds and millimeters. The alien craft's instability grew. Its phased envelope now flickered between coherence and semi-existence, exposing larger areas to kinetic strike. Odyssey's drones exploited every fluctuation, striking repeatedly with precision, while the lattice arrays amplified feedback loops to maintain the craft within the phase bubble. Despite persistent countermeasures, the craft began to exhibit visible deterioration. Segments of its hull warped, energy pulses became erratic, and the smooth symmetry of its interface fragmented under the sustained assault. Yet it remained operational, its adaptive systems still responding with intelligence and persistence, suggesting that full neutralization would require continued, relentless pressure. At a critical juncture, a section of the aft truss experienced a near failure. The lattice oscillations, under cumulative stress, resonated with local structural mass, producing harmonic vibrations that threatened to shear connections. Crew members manually reinforced nodes, diverting all available energy to stabilizers. One technician sustained severe injury during the operation, but their actions prevented catastrophic collapse, allowing the offensive to continue. The human cost underscored the stakes. The battle was waged not only in the abstract realm of quantum fields, but in the tangible reality of bodies, materials, and mortal endurance. The culmination of the multi-vector assault approached. The alien craft, now partially destabilized, reacted with desperate measures. Its energy output intensified, producing surges that interfered with lattice oscillations, causing temporary failures in auxiliary power and microgravity stabilizers. Odyssey shuddered violently, and emergency dampers engaged to compensate for sudden momentum shifts. Crew members navigated hallways illuminated by erratic emergency lighting, adjusting conduits, recalibrating sensors, and reinforcing structural supports under extreme duress. The operation had reached the limits of both human and technological capability. Every action, every decision carried amplified consequences. Survival depended on the precise synchronization of observation, manipulation, and intervention. In the final moments of engagement, Odyssey's systems achieved a delicate balance. The alien craft was forced into a stabilized phase state, partially manifested in their dimension long enough for concentrated kinetic and lattice pulses to overwhelm its adaptive mechanisms. Hull integrity of the craft was compromised extensively, energy outputs fluctuated uncontrollably, and its previously flawless symmetry fractured. Each strike was measured, calibrated, and executed with ruthless efficiency, combining the cumulative knowledge gleaned from weeks of observation, experimentation, and incremental assaults. The alien interface, while still partially coherent, could no longer sustain full operational capacity. The balance of tactical initiative had shifted decisively toward Odyssey. As the craft faltered, residual telemetry from the mirror station suggested a deeper revelation. A portion of its interface retained traces of intelligence, potentially analogous to sentience, struggling to maintain cohesion under the sustained assault. This insight reframed the operation from pure destruction to containment and observation. Commander Marlin adjusted deployment patterns, guiding drones to maintain pressure without completely annihilating the vessel, while lattice arrays stabilized regions of structural integrity for analysis. The station's crew acted with both precision and restraint, aware that their actions carried consequences across dimensions, and that the alien craft represented more than a simple enemy. It was a nexus of intelligence, physics, and unknown ethical implications. By the conclusion of the multi-vector operation, Odyssey had inflicted critical damage on the alien craft while maintaining structural integrity. The station itself bore the marks of sustained strain. Trusses reinforced, conduits rerouted, auxiliary power cycling at maximum capacity, and crew physically and mentally exhausted. Yet the victory was profound. The alien's operational capabilities were compromised, its phase interface partially stabilized, and critical vulnerabilities revealed. Odyssey's crew had not only survived, but gained actionable intelligence, refining strategies that could guide future engagements and potentially open avenues for communication, containment, or negotiation with forces that had once seemed incomprehensible. In the quiet aftermath, the station drifted in orbit, its magnetic dampers and lattice arrays oscillating at low frequencies to stabilize residual perturbations. Crew members monitored every system meticulously, repairing microfractures, recalibrating sensors, and reinforcing structural supports. The alien craft hovered nearby, its interface flickering intermittently, partially coherent but subdued, a tangible reminder of the complex theater they now inhabited. Odyssey's crew recognized that the engagement had fundamentally altered their operational paradigm. Survival was no longer solely a matter of shielding and firepower, but of coordination, observation, and ethical decision-making within a multidimensional framework. The consequences of the battle extended beyond immediate survival, shaping doctrine, technology, and human understanding in ways that could not yet be fully grasped. As orbital night fell over Earth, the alien craft remained partially stable. The lattice arrays hummed softly in resonance with the ship's systems. The crew rested in staggered shifts, repairing what could be repaired, analyzing what could be analyzed, and preparing for the next inevitable encounter. The lessons of the multi-vector operation were clear. Tactical ingenuity, human resilience, and precise manipulation of multidimensional physics had produced victory. Yet the war, strategic, ethical, and multidimensional, was far from concluded. Odyssey's crew understood that the coming engagement, wherever it occurred, would demand even greater coordination, creativity, and courage. And, in the quiet pulse of the station's auxiliary systems, the weight of possibility pressed forward. The endgame loomed, not merely as survival, but as a test of humanity's capacity to confront forces beyond comprehension, with discipline, insight, and sacrifice as their only weapons. Odyssey Station rotated slowly in the shadow of Earth, the hum of auxiliary generators blending with the faint oscillation of lattice arrays that held the alien craft partially stabilized. Its hull flickered between coherence and semi-existence, a living puzzle of quantum phase matter that defied conventional understanding. Crew members moved through corridors illuminated by soft emergency lighting, their movements deliberate, every action measured against fatigue, structural risk, and the uncertainty of the unknown. The final engagement required precision, coordination, and courage, an operation where human judgment, robotic intervention, and multidimensional physics converged at their limit. Commander Marlin stood at the observation deck, hands clasped behind his back as he surveyed the alien craft through reinforced viewports. The object had been degraded by previous assaults, but remained coherent enough to pose lethal threat. Its adaptive energy pulses now exhibited predictable decay cycles, a pattern that had emerged from weeks of observation and multi-vector engagements. The plan was audacious: force the craft entirely into Odyssey's dimension for a controlled engagement, neutralize its energy core, and extract residual intelligence for analysis. Success depended on absolute synchronization, drones, lattice fields, thrusters, and human oversight all operating in concert. Failure could collapse the station, or worse, irreversibly destabilize the overlapping realities. The operation began with calculated precision. Drones launched simultaneously from multiple vectors, their paths choreographed to intersect at precise nodes around the alien craft. Particle arrays oscillated in phased sequences, creating controlled distortions designed to trap the craft within the lattice's influence. Auxiliary thrusters micro-corrected Odyssey's rotation to align structural mass with predicted interference zones, while power relays surged to maintain maximal energy output. Every second was monitored, analyzed, and recalculated. The station's entire crew operated as a single organism, a network of eyes, hands, and minds intertwined through technology and discipline. The alien craft reacted with immediate awareness, its movements a blur of phased acceleration and evasive maneuvers. Pulses of energy struck Odyssey's shields with precision, testing the limits of lattice reinforcement. Hull panels vibrated with resonant energy, conduits strained under shifting magnetic loads, and emergency dampers engaged to prevent structural collapse. Yet the carefully prepared interference patterns held, compressing the craft's phase envelope incrementally. Small sections flickered fully into Odyssey's dimension, exposing points of vulnerability for drone strikes. Each hit produced visible fractures in its adaptive hull, energy pulses spiraling unpredictably, a tangible sign that the operation was succeeding. Within the corridors, technicians performed acts of improvisation and bravery. Microgravity corridors were fraught with snapping cables, sparking conduits, and fluctuating magnetic fields. Personnel navigated these hazards with magnetized boots and tethers, manually rerouting power, reinforcing trusses, and stabilizing lattice nodes. Several drones were sacrificed deliberately, their destruction drawing the aliens' attention and opening windows for other units to strike with precision. Injuries occurred, burns from redirected plasma conduits, blunt trauma from sudden momentum shifts, but the crew pressed on. Survival depended on both physical resilience and the capacity to act decisively under extreme pressure. Alara monitored the lattice arrays, her eyes fixed on data streams representing overlapping phase fields, energy gradients, and structural stress. Predictive algorithms ran in parallel with human intuition, feeding micro-adjustments to oscillation frequencies and amplitudes. She manipulated subtle distortions to exploit the craft's adaptive lag, forcing it to manifest more fully while avoiding overexposure that could destabilize the station. Every decision balanced risk and opportunity, requiring real-time assessment of consequences across multiple systems and dimensions. The hum of the lattice arrays became a pulse, a rhythm guiding the offensive with precision beyond human comprehension. The alien craft's responses began to falter. Its energy pulses became erratic, adaptive surfaces fractured under sustained pressure, and segments of its hull exhibited delayed phase corrections. Odyssey's drones exploited these windows relentlessly, striking exposed areas while maintaining protective formations around critical station modules. Feedback from lattice arrays created controlled micro-instabilities that further trapped the craft, reducing its maneuverability without catastrophic rebound. The operation had become a symphony of coordination, improvisation, and technical mastery, a convergence of human ingenuity and scientific insight applied under conditions of extreme duress. Yet the cost was palpable. Auxiliary power modules overheated, emergency circuits tripped repeatedly, and structural stress approached critical thresholds. Crew members worked in shifts with minimal rest, some suffering from fatigue-induced tremors while recalibrating sensitive instruments. In one corridor, a technician sacrificed themselves to manually seal a venting conduit, preventing catastrophic depressurization. Their actions allowed the operation to continue, a grim reminder that human resilience and bravery were as critical as any technological advantage. Marlin acknowledged these sacrifices silently, knowing that victory required both precision and the willingness to accept cost. As the alien craft became increasingly destabilized, its energy core emitted intense, fluctuating pulses. Alara calculated that a final concentrated lattice modulation could force full manifestation while minimizing risk to Odyssey. Auxiliary thrusters aligned the station's mass, drones positioned at precise vectors, and particle arrays oscillated with maximal amplitude. The craft flickered violently, fully entering their dimension long enough for a decisive strike. High-density projectiles impacted the exposed core, producing controlled disintegration while lattice fields absorbed excess energy. The alien interface reacted with uncontrolled pulses, attempting adaptive correction, but the accumulated pressure proved overwhelming. The energy output collapsed, its coherence fractured, and the craft's adaptive systems ceased coordinated activity. In the aftermath, the station trembled under residual oscillations. Hull panels bowed, auxiliary systems cycled emergency protocols, and the corridors were littered with debris from microfractured conduits. Crew members navigated cautiously, performing immediate repairs while monitoring for secondary failures. The alien craft, partially intact but inert, drifted in orbit as a massive, flickering shell, a testament to the limits of its adaptive systems and the precision of Odyssey's offensive. Alara began preliminary analysis, extracting residual energy patterns and structural data, hoping to glean insights into the parallel civilization's technology and intent. Every observation carried significance, a window into forces that operated beyond conventional physics. Despite success, the human cost remained evident. Several personnel were injured, some gravely, and fatigue permeated the crew. Structural stress had damaged critical modules, requiring extended repair cycles. The operation had demanded the utmost coordination, ingenuity, and sacrifice. Yet the victory was real. The alien craft's offensive capability was neutralized, critical intelligence was accessible, and Odyssey Station remained operational, albeit strained. The lessons of the engagement were profound. Survival and victory depended on the interplay of disciplined execution, improvisational decision-making, and the precise application of multidimensional physics. In the quiet that followed, the station's crew assessed damage, stabilized systems, and began consolidating data from the alien craft. Lattice arrays operated at low amplitude to maintain structural integrity. Auxiliary generators cooled gradually, and emergency lighting transitioned to standard illumination. The alien shell, inert yet containing residual energy fields, provided both a source of insight and a reminder of the stakes they had faced. The station's personnel moved systematically, documenting damage, recording observations, and preparing for the potential of renewed engagement. The operation had tested the limits of human endurance, technological capability, and strategic coordination, and had proven that even against forces partially existing in another dimension, discipline, ingenuity, and courage could prevail. Marlin surveyed the observation deck, noting the condition of both Odyssey and the alien craft. He understood that the engagement had fundamentally altered their understanding of reality, physics, and the potential for interdimensional conflict. The station had survived through a combination of precise coordination, human sacrifice, and exploitation of vulnerabilities, revealed through patient observation. The alien craft's defeat was not a simple destruction, but a measured neutralization, preserving opportunities for study and insight. It was a victory defined by strategic brilliance, tactical discipline, and the human capacity to act decisively under unprecedented conditions. As Earth rotated below, the crew began the slow process of recovery. Microfractures were repaired, lattice arrays recalibrated, and auxiliary systems stabilized. Data harvested from the alien craft was stored for analysis, promising insights that could inform future defensive strategies and technological innovation. The human cost, injuries, fatigue, and the memories of sacrifice was acknowledged but integrated into the operational record. Odyssey Station, battered yet intact, had survived a confrontation that tested both the limits of human capability and the resilience of the human spirit. The alien craft, inert but informative, represented both a triumph and a challenge for the future. In the days that followed, the station's crew continued to refine operational protocols, analyze residual energy fields, and integrate lessons learned from the engagement. Structural reinforcements were strengthened, auxiliary power distribution optimized, and tactical simulations conducted to prepare for potential recurrence. The victory over the alien craft was significant, yet its implications extended beyond immediate survival. The encounter had demonstrated the feasibility of manipulating multidimensional interfaces, exploiting vulnerabilities in phased matter, and coordinating complex operations under extreme duress. Humanity had endured, adapted, and prevailed, not through luck, not through convenience, but through disciplined execution, ingenuity, and collective resolve. As Odyssey Station drifted in orbit, the alien craft inert but still present, a sense of cautious optimism settled over the crew. They had confronted a force that defied conventional understanding, leveraged human and technological ingenuity to overcome it, and survived to document and learn. The engagement had reshaped operational doctrine, informed new approaches to phased energy manipulation, and highlighted the enduring importance of human judgment in concert with technology. And in the quiet hum of stabilized lattice arrays, the station's crew understood that the challenges of interdimensional engagement were only beginning, but that with discipline, coordination, and courage, humanity could confront even the most incomprehensible threats and endure.